Continuing with probability, we're going to do a little set theory. We're going to look at outcomes and classify them in sets. So a set is simply a collection of things. It can be numbers, it can be objects, it can be a lot of stuff. And they satisfy a well-defined criteria. We don't want to be wishy-washy. The things that are contained in the set are called elements. So let's jump right into an example. You are going to make a set and you are going to call it set A. And you are going to define set A as the numbers inclusive from 1 through 10. It's well defined. I didn't say the numbers from 1 through 10. I said inclusively. That means I have to include 1 and 10, so there's no arguing, well, through doesn't have to mean 1. It's well defined. And then we want to look at the elements. And there's 2 ways we can list this set. We can write it in set notation, which is probably the easiest. Set notation simply means this. We use brackets, and then we list all the numbers 1 through 10 inclusively. Then we have a little thing called a Venn diagram. So a Venn diagram looks like this. I wrote my numbers 1 through 10 inside a circle, and we define this circle to be called set A. The box is called a universal. Just like we have a universe, and within our universe we have planets and stars and meteorites and everything else. So this is the universal, this is the set of everything, and then this is the set A. So set A is a subset of the universal. So a subset means that the new sets can be part of a larger set. So set A is a subset of the universal. Now likewise, I can create yet another subset. For example, let's say I wanted to create the subset 1, 2, 3. Now in set notation, that's what we have. And we could say, let's call this set B. And we could say set B is a subset of set A. So yeah, I know that looks like the letter C, but it's not. It's supposed to be, let's see if I can draw this better. B is a subset of A. Now, if I were to draw a subset in Venn diagrams, it would look something like this. I'm going to have to draw my Venn diagram all over again because it would say, okay, here's my universal. Then I have a set that contains the numbers 1, 2, 3, and that set is also in set A. And set A contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we have our universal. And then we can say elements. So 1 is an element of set B. 1 is also an element of set A. And 1, of course, is an element of the universe. Kind of cool, but we're not really getting into set notation and theory, but I thought I'd just show that to you. All right, we are sticking with probability. So we're going to have a sample space here that represents where we first tossed a coin, we noted the outcome, and then we rolled a 6-sided die and we noted the outcome. So in other words, we rolled a head, we tossed and we got a head, and we rolled a 1. Toss, we got it. So this is our sample space as we noted above. Now from our sample space, we're going to look at this as sets. And if we can understand sets, then it might help us understand probability better. So write the set of ordered pairs that represents the event of getting a tail and then an even number. All right, so if I come up here, well, the first row is totally out because all that's heads. So here's a tail with an even number, Here's a tail with an even number, and here's a tail with an even number. There, there, there. Okay, that was easy. Ooh, complement again. Oh, complement meant yesterday. Oh, we didn't learn complement yesterday. My bad. Complement is a new word. The complement of set A would be everybody we didn't pick. Oh, well, we picked the guys that were in this space, so the complement is the leftovers. Now we can call that whatever we want. In this case, I decided to call it set B. And for notation, we could say the complement of A, we put a line over it. So this could mean complement. So you would know that means everybody not in A. And then this would be the complement of B, everybody not in B. Another way to write complement would be with using a prime symbol. So A prime also means the complement of A, and B prime also means the complement of B. So now, why are we learning all this? Because this may help us figure out the probability of event A and the probability of event B easier if we can see it in set form. Consider rolling a six-sided dice and recording the result. Set A is the event of rolling a number greater than 4. Okay, so set A is rolling a number greater than 4, and set B is the complement of A. All right, so in my head I know rolling a number greater than 4. Well, that would be 5 and 6. Write that in black. 5 and 6. And the complement is everybody not 5 and 6. So if I'm rolling a six-sided dice, that means it's 1, 2, 3, and 4. Well, how's that going to look like in a Venn diagram? Well, the universal would be the numbers 1, 2, 3, 4, 5, 6. And then we have two sets. We have set A, which are the numbers 5 and 6. And we have set B, which are the numbers 1, 2, 3, 4. And they do not cross. There's no number that's the same. So if I took the probability of A, well, there's 2 events happening in A out of a total of 6. And there are 4 events in set B. We add them together, and we get 6 over 6, which equals 1. So really, this is easy. What we learned is the probability of event A happening and the probability of event A not happening, everybody outside of A happening, always adds up to 1. Get it? 100%.